All right, what's up, everybody? We have another lesson coming at you today. This one is about friction. So here we got a picture of a match going against some really rough surface, and it creates a ton of heat. You may have noticed that when you rub your hands together, it gets really hot and your skin starts to burn off and gets all gross. That's a great example of friction. So let's define it and then talk about it. There's 4 different types, but we'll get into that. But friction is defined as the force that resists motion. Very simple, okay? And that makes sense, you know. You go to push an object, and why does it end up stopping? Well, it's because of friction. All right. Why is it hard to push something? Well, it's because of the friction. It's resisting motion. Something doesn't want to move. So we'll get into 4 different types. Some of them are similar than others, but we got static friction, we got sliding friction, we got fluid friction, and we got rolling friction. So let's take a look. In this picture, you got a rock climber, right? What do rock climbers typically do with their hands? Well, they put chalk on it. And why do they do that? They want a better grip on the rocks. They want to increase that friction force between their hands and the rock. And by doing that, by putting powder on it, it gets stronger. That force gets stronger so you don't slip as much. All right? So this is an example of static friction, the friction force that acts on objects that are not moving. So another example of this would be, you got a refrigerator, right? And your mom wants you to move it from one side of the house to the other. All right? Big task. Now, let's say it's very heavy. It's going to be hard to move that fridge. You have to put a lot of force. But let's say you're pretty weak. You can't move it at all. The reason it's staying in place is because of static friction. All right? It's not moving, so that static friction force is opposing you. Now think about it. Does static friction increase or decrease as something gets heavier? Well, as something gets heavier, it's going to increase because it's harder to push because that static friction force increases. All right? Another example of this, if you get a chance to, look up on YouTube Mythbusters phone book. They overlap all the pages of 2 phone books so that it's basically one big phone book meshed together. And they try to split it apart, and it ends up taking a lot of force to do that. And that's because of static friction. All the pages of the phone book add up together to a ton of static friction. Something very similar to static friction is called sliding friction. Now, think about a time that you went sled riding. You go down the hill, and what eventually happens? Well, you eventually stop. And that's because of sliding friction. You got your sled sliding across the snow, but there's a friction force there that opposes the motion of your sled, and you eventually come to a stop. So this is the friction force that opposes the motion of an object as it slides across a surface. Another example is a skier. You know, you think about that. And this is related to static friction. Let me show you how. So you got this flower pot here, and let's say you're trying to push it to the left. We're looking at scenario A. You're pushing it to the left. Well, let's say it's really heavy. Why isn't it moving? Well, it's because that static friction force is keeping it from moving. If you notice here, that arrow is the same length as the arrow over here. We call that a vector. Arrows are just vectors, or vectors are just arrows with direction, okay? So here we go. We're pushing on the left, but it's not moving because that static friction force is canceling it out. All right, it's resisting that motion. So what you have there is you have balanced forces. Scenario A is balanced. The motion is not changing. Look over here at B. You start pushing hard enough, what's going to happen to that flower pot? It's going to want to move, right? So you push hard enough, it's going to move to the left, and it's going to slide across the surface. Well, sliding, okay, that's sliding friction. So over here we had static friction because it wasn't moving. Over here we have sliding friction because it's sliding across the surface. Well, what do you notice about the arrows? This arrow, the push force, is much greater than the sliding friction force. That means it's unbalanced. There's more force pushing it to the left than there is to the right. So if it's unbalanced, that means it has a net force that isn't 0. It's going to be wanting to go wherever the force is greater. And the force is greater pushing on that right side, and it's going to go left. You see that? So the potted tree accelerates to the left. Now it's important to note here, notice friction, the direction of the arrow is exactly opposite the push force. That makes sense because friction is defined as the force that opposes motion. All right, so that's static friction and sliding friction. There's another type called fluid friction. So when you think of a fluid, you typically think of some sort of liquid. And the example I like to do is you're making cookies, right? And you add flour, you add the mix to whatever the liquid ingredients are, eggs, water, oil. And the more you add of flour, you notice the harder it is to stir. And the more chocolate chips you add because you like chocolate chips, the harder it is to stir. And that's because of a friction force called fluid friction. It's the friction force that opposes the motion of an object through a fluid. It's important to note that a fluid is a liquid or a gas, so that includes air. Air and gases are a fluid. They are considered a fluid. So there is a subcategory in fluid friction called air resistance. Now you look at this little guy, he looks like a flying square, but he's a flying squirrel. And what forces are acting on him? Well, we all know that gravity acts on everything here on Earth. So gravity is pushing down. But what is keeping him up? Well, that's air resistance. And it's opposing his motion. Well, opposing motion is a type of friction. That's what friction is. It opposes the motion of an object. So fluid friction, air is a fluid. Fluid friction is what's pushing him up. It's called air resistance. All right? Air resistance is a type of fluid friction. It's friction caused by air. So that's why this little guy is able to stay afloat. It's because air is opposing its motion downward from gravity. You see that? So there's one more example, and that's rolling friction. Here we got Messi, all right, playing for Argentina. He likes soccer. He likes to kick the ball. And the ball, after it's kicked, is going to roll around the grass for a while. Now, what happens after it rolls around? If no other forces are acting on it, it's going to come to a stop. Well, what force made it come to a stop? That's rolling friction, all right? The friction force that opposes the rolling of an object. Now, it's important to note, rolling friction is 100 to 1,000 times weaker than sliding friction. Now remember, sliding friction is something sliding across the surface. Rolling friction, it's got to roll across. Now, the way I think about it is, if you want to move something heavy from one side of the room to the other, would you rather slide it or put it on wheels and roll it? Well, it's going to be much easier rolling it because rolling friction is a lot weaker than sliding friction. It's going to be much easier to overcome that friction force and to get the object to accelerate if it's on wheels than if you're just sliding it. That's why we have cars with wheels on them. Can you imagine a car without wheels going on the highway? It's just going to skid and stop very quickly because that friction force is very strong if it's sliding friction. With rolling friction, it's a very weak force, so it can keep going for a while. All right, so those are the 4 different types. And friction opposes motion. Remember that key term.